A model rocket generates is due to the pressure from the gases in the rocket system's engine.
When the rocket is launched, the engine ignites and the gases that are produced by the combustion of the engine's fuel are expelled out of the back of the rocket, which generates the force that propels the rocket into the air.
The amount of force that a model rocket can generate depends on the size of the engine that is used to power it. The larger the engine, the greater the force that the model rocket can generate. Additionally, the shape of our rocket and the size of the fins can also affect the amount of force that our rocket can generate. During our rocket model launch, the velocity increases as our rocket accelerates.
The greater the thrust that is generated by the engine, the greater the velocity of the rocket will be.
Its velocity will continue to increase until it reaches its maximum velocity, at which point the acceleration will be zero.
At this point, the rocket will continue to travel at a constant speed until it reaches maximum altitude and begins to descend back to the ground. During our launch, the gravity affects our rocket by pulling it down towards the ground.
The force of the gravity acts on the rocket's mass, which can make it difficult to achieve the rocket's liftoff. However, once the rocket has lifted off the ground, the force of gravity continues to act on the rocket, slowing it down and eventually causing it to fall back to the ground.
In order to overcome the force of gravity, the rocket's engine must generate enough thrust to lift the rocket off the ground and continue to accelerate through the air.
Momentum is a measure of object's mass and velocity. The larger the rocket, the harder it is to accelerate.
The faster the rocket is traveling, the more momentum it will have, which will be harder to change its direction.
This means the rocket must generate enough thrust to create a liftoff.
The momentum of the rocket will cause it to continue in a straight line unless acted upon an external force, such as wind. The rocket's momentum will be determined by how high it will be able to travel and how far before hitting the ground. During our launch, the projectile is considered our actual rocket. As our rocket is launched, it moves through the air influenced by gravity.
Newton's first law describes that once an object is in motion, it stays in motion, and once an object is in rest, it stays at rest.
Newton's second law of motion states that the force acting on an object is equal to the mass of an object multiplied by its acceleration. In the context of a model rocket launch, this means that the amount of thrust generated by the rocket engine, which is the force acting on the rocket, is determined by the mass of the rocket and the acceleration that it needs to achieve in order to launch successfully. Finally, Newton's third law of motion states that for every action there is an equal and opposite reaction in the context of a model rocket launch. This means that the force generated by the rocket engine, which is in action, is met with an equal and opposite force that propels the rocket through.
Paraboletic trajectory is the path that a model rocket follows as it travels through the air, which means that it follows a symmetrical U-shaped curve that is formed by a graph of a quadratic function. This is determined by the rocket's velocity of the force of gravity acting on the rocket. The shape of the parabola is determined by the angle at which the rocket is launched at and the amount of thrust generated by the engine. The vertex of the parabola curve represents the highest point at which the rocket's trajectory is. As seen before, a rocket did actually launch. As it launches, our rocket gains speed, which is kinetic energy. As our rocket is on the ground, the potential energy is zero. As it moves up in the vertical direction, the potential energy will increase.
During our model rocket launch, the rocket is experiencing a force known as thrust, which is generated by the rocket's engine. The thrust causes the rocket to accelerate or increase its velocity as it travels through the air. The amount of acceleration that the rocket experiences is determined by the amount of thrust that is generated by the engine as well as the mass of the rocket itself.
The greater the thrust that is generated by the engine, the greater the acceleration of the rocket will be. As the rocket travels through the air, it loses some of its mechanical energy due to the air resistance and friction.
The mass of a model rocket affects its trajectory during launch in a few ways. First, the mass of the rocket determines how much force is required to launch it. Second, the mass of the rocket affects its acceleration. A heavier rocket will accelerate more slowly than a lighter rocket, which can affect the rocket's trajectory. Third, the mass of the rocket affects its stability. A rocket that is too heavy for its size may be unstable and may not follow a straight trajectory during launch. Finally, the mass of the rocket affects its descent. A heavier rocket will fall back to Earth more quickly than a lighter rocket, which can affect the rocket's landing.
Power is the rate at which energy is transferred and transformed. During our model rocket launch, power is used to launch the rocket and maintain its flight. The launch pad is a machine that is used to hold the rocket in place before the launch and to provide a stable platform for the rocket to launch from. The rocket engine is also a machine that is used to generate the thrust that propels the rocket through the air.
Trajectory is the path that an object follows as it moves through the air. During a model rocket launch, the trajectory of the rocket is determined by a combination of factors, including the angle at which it is launched, the amount of thrust generated by the engine, and the mass of the rocket itself. The trajectory of the rocket follows a curved path known as a parabolic trajectory, which is determined by the rocket's velocity and the force of gravity acting on the rocket. The rocket is launched at an angle which determines the initial direction of the trajectory. As the rocket travels through the air, it follows a curved path that is determined by the force of gravity pulling it downward.